So participants, I'm sharing my screen. If you can see my screen, please do confirm the same. Participants, if you can see my screen, can you please type in
Yes,
yes into the chat
yeah,
window?
it is visible.
Yeah, we can. Yeah, we can.
Okay, cool. So once again, very good morning to all the participants joining this session. I myself, Siddharth, I'm your trainer. So I would request you, please follow the instructions. Can you please mute yourself during the demonstration because there is a lot of background noises that are overlapping my voice. Thank you very much. So participants, as you are aware, this is a demo session where I'm going to go ahead and give you a walkthrough about our course that is MLOps. So what is that I'm going to do? First thing is I'm going to introduce about myself. Then what I'm going to do is I'm going to give you a quick walkthrough about this entire learning program of what is exactly MLOps. During that, if you have any questions that you want to go ahead and discuss with me, please feel free to ask me. You can use your chat. The best thing that you can do is you can use your chat and drop me the message in the form of your questions in the form of messages into the chat so that I can take one by one so that I don't miss out your questions. If you're still not getting the clear picture of the question that you have asked, you can take these questions to the end of the session where I'm going to give you enough time to articulate your question. You can open up your mic, you can ask your questions, and I'll be able to answer them. So, participants, are we all excited? If you are all excited, can you go ahead and give me a yes into the chat window, please? Can I have a quick yes from you from your chat by typing yes so that I can get started? Okay, fair. So let me go ahead and quickly introduce about myself, participants. I myself, Kumaran Siddharth Sukumaran. I'm based out of India and I'm a multi-cloud consultant working on machine learning platform for the cloud practices involving AWS, Azure, GCP, and other clouds, where my primary responsibility as part of my job role in my company, I go ahead and build models along with my team, where we go ahead and release these models into the prod so the customers go ahead and use it or the internal organizations use it. So we build a lot of we work on a lot of data. We go ahead and build models that has ability to do some kind of predictions. So we are a team where we follow the DevOps principles to release our applications. That's how the formulation of MLOps happens. So I'm going to talk more about it. So coming up to my total years of experience, I have about 10 plus years of experience. I'm a certified consultant on machine learning. I've been certified by AWS, Azure, and GCP, and I'm currently working into a project where we use all the different kind of clouds for our model development and deployment. So participants, you are in safe hands. So with that, let me get into the topic. Now, the topic is all about MLOps. Now, this is very, very buzzing in the market. Uh, my experience with MLOps is around about 6 years now. It's past that I'm very, very lucky that I got an opportunity to work with my company to do the machine learning ops. So before that, I was into basically machine learning development and I was delivering the machine learning applications, but I have opted to, release the application. So that's how I become an MLOps engineer. So the delivery program is all about MLOps. Now, as I mentioned, this is a very trending subject and this is a very trending course that is actually accepted by a lot of companies. So why it is important? Let's understand a very simple mathematics and we'll try to understand about it. So if you look at the MLOps adaptation, if you just go ahead and type in MLOps adaptation and if you just type in MLOps adaptation or just type in adaptation. So what is the point that I want to know? How many companies are adapting to this process? So let's go ahead and see the MLOps adaptation graph and so that you'll get a clear picture that how many companies are taking a grant for it. So for this, I am going to go ahead and give you the market share. So how companies are expected to go ahead and build the applications. So this is one example that you can see that the market segmentation has been growing a lot. That a lot of companies are moving their applications, by getting those applications built. So this is on-prem. So you can see here there are two narratives. One narrative that is on premises. So I'm getting it from a market research page where they have given that the acceptance for MLOps onto the cloud versus on premises. So for the year 2022, it's been there, uh, very nominal, but if you see, it is exponential growth in the matter of 10 years. And the cloud is also going to grow ahead and raise exponentially. So imagine you are right now in a stage where this is a growing industry. That means there are a lot of opportunities coming in. So you should be part of this. So my point is that be part of this, expansion, be part of this, what you call it as, be part of this change that is happening in the industry. So a lot of companies are making their way into the market of MLOps. So you be better part of it. Now, it is very easy for me to say that you be part of it. Now it is for me to go ahead and justify that the statement that I made that you should be part of this should be justified by some technical facts. Technical, I should bring some information to you that should be meaningful, right? When I say something, I should be, supporting it by facts. So let me go ahead and get all the facts for you that how is that you should get adapted to the MLOps, and what are the kind of opportunities you have, what are the skills that you need to build, what is the learning that you should do so that you can be part of this growth which is going to happen. Now, to understand this, we need to understand two key things. What are the two key things? From my side, what I suggest you should basically understand the two key things that I was talking about is one, you should understand what is a concept of give me a minute. Okay. Now let me go ahead and use my cursor. So you should understand these two things, part. So to understand MLOps, you need to understand two primary things. That one is machine learning, you should understand. And there is a hidden term which you may not go ahead and see, but it is actually something called DevOps. So when you go ahead and find these two terms, that's how the concept of MLOps came into picture. So participants, everyone, are you with me? Can I have a quick yes from all of you? So there are two key things that you should understand. ML plus the ops, that is DevOps. The ops from the DevOps you should understand. If if you people are following me, can I see a quick yes from all of you? I could hardly see one or two people confirming me. So Pavan says yes. Eric says yes.
Yeah, we can hear you. Yeah.
Okay. So now the point that you should understand is I have started with the concept of MLOps, that how opportunities are going to happen for MLOps. There is a huge market for MLOps. Can I request participants, can you please go on mute if you don't mind? Thank you so much. Right. So how did I start it? For those people who have just joined now, I did start it where I just mentioned that there is a humongous growth that is going to be happening in the space of machine learning. The MLOps, market, the market for MLOps is growing very fast, both on premises as well as on cloud. So if you look at the cloud as well as on premises, it's equal, and a lot of opportunities are coming up in the next term to go. Now, the point is, you should be part of this change, right? You are required to go ahead and build a skill of machine learning and ops, ML ops together so that you can be part of this revolution. So whether it is an on-prem or cloud, you will get opportunities. Now, the point that I started was this, and the next step that I wanted to go ahead and discuss is, let me go ahead and justify by end of this session that what are the skills, learning, strategy, or what exactly you should adapt to all of it so that you can build yourself as an MLOps engineer. That means when you go to an interview, when you go and talk to a company, you should be justifying that yes, I am a certified MLOps engineer. I am a right candidate for this position. So you should hire me. So for this, you need to know what is MLOps and what are the concepts behind it and how to code and learn, where should you learn, what is that you should learn and what is that you should not learn. This is what we will go and discuss. So I've started by discussing that if you want to understand MLOps, you need to break down into two parts, machine learning and the concepts of DevOps. That's how the MLOps came into picture. Okay. Now, let me take a little further that what exactly is MLOps or what exactly is ML in this MLOps is, right? So in real world participants, we know that if you go ahead and give in an input, right? We in real world, what we do is we go ahead and give an input. So what is going to happen based upon an input? You will go ahead and find a relation based upon the input. You just basically get an out. Correct me, everyone. That means if you go ahead and give an input, based upon the input, you will get an output. Correct me, everyone. So if you know the value of input, if you go ahead and give an input, you are expected to go ahead and get the output. Correct me? Am I correct? Let's say the value of output is sometimes dependent on input, right? But what happens in the machine learning? It is very different. In machine learning, we know the input. The funniest thing is we know the input and we also know the output. Participants, everyone, are you with me? We know the input, we know the output. Now we need to go ahead and identify what is this relation. That's how machine learning comes into picture. If you understand this logic, participants, you are making a great entry into machine learning. Everyone, are you with me, people? Hello? See, if you
Yes,
know an
yes,
input,
Yes.
right, you will get an output predicted. For example, if the value of x is 100 and the value of output is 2 times of input, 2 times of 100 is 200. We know that it is input, we got an output. Now I'll give you input, now I'll give you output. I'll ask you to go ahead and identify the relation of x. For example, if you go to our school mathematics, we have learned that a plus b whole square is equal to, if you look at the numbers, you will know that a square plus b square plus 2ab. Now, what I want you to do is I want you to go ahead and identify the input and output. I want to identify what is the relation between that how A and B are related. Everyone, are you with me? Can I proceed with this definition? So, if you want to understand machine learning, you should understand this core principle that you are aware of an input, you are aware of an output, but what you are looking is to identify the relation. Is that how your relation among the data is that? So once you know the relation, then you can go ahead and predict what could be the possible output, what could be possible input. That means based upon an input given, you can now start predicting the output as well. Correct me, everyone. I'll give you a simple example. I know it is becoming a little difficult for you to understand. So let me give you a very simple example that you can easily relate with. So let me just go ahead and give you this point. Let me just take an Excel sheet. Okay, so what I'll want is let me open up an Excel sheet and let me give you some relations so that you can easily understand the concept. So let's say I have a value of X, right? The value of X, or let me give a real life example. Let's say I have some area and I want to go ahead and predict the rental price of that. So if the area is something around $1,000 or 1,000 square feet, the rent is given something. The real value is something like 2,000, 25,000 INR. And if it is something around 1,200, so what I want to do is I want to go ahead and identify. Uh, just give me 1 second. 1,200 is around 27,000, followed by something like 1,500. I something like an expect is around 30,000. Now, the point that I want to drive is very simple. I hardly have three data points, that is area of three properties, and I have the rent of the three properties. Now, what is that I'm guessing? If the area is increasing, the rent will also increase. So if I can go ahead and identify the relation between area and rent, next time when there is a rental property that I need to go ahead and give, I should be able to go ahead and tell that based upon the area, if the area is about something like 1800 square feet, this could be possibly the price of the rent. Okay, let's assume the real value of the rent that was given is around 35,000. But what I've done, I did some little bit of mathematics, I did, and I found that, this is able to go ahead and do a prediction of the price it has predicted. So I'll put it as predicted. That means we are predicting the rent, predicted rent. Instead of 35,000, it has predicted something, say 33,500. So how much is the difference? The difference is 1,500. What is that 1,500? The difference. That means the real value was 35,000, but the training has predicted something around 33,500. That means it was shortfall of 1,500. Now what I'll do, instead of focusing only on 3 data points, I want to increase more in number. I want to make it to 3 to 100, 100 to 1,000. That means more data is coming to me. I'll be able to go ahead and give better prediction. Next time when I did, it started to predict something like 34,000. That means the difference is coming to from the real value to the predicted value. Now it is coming to 1,000. Next time I did one more data. I brought one other set of data. I started to train it. Now it started to predict 34,000 from 600. So see, slowly it is coming down from the predicted value to real value. Now, if I ask for 3 data points, you and me can identify. Correct? If there are only 3 data points, you and me can identify. But imagine if there are 30,000 records. 30,000 records. Will you be able to go ahead and do that? That means, will you be able to go ahead and identify the relation among those 30,000 records? Participants, is it humanly possible for you and me to go ahead and identify the 30,000 endpoints? Absolutely no. We cannot do that. We cannot do that. So what we'll do, we'll go ahead and knock the door of machine. Hey, machine, good morning. How are you? I'm giving you good amount of RAM. I'll give you good amount of RAM. What you do, you just go ahead and identify the relation between area and rent. So what it will do, it will go ahead and permutation and combinations. Let's say 30,000 records. Let's say even let's start with number 3 so that becomes easy. So 3 records I have. So how many times it can do training if I go ahead and multiply? There are area and rent. That means 3 factorial 2. I hope in your schools we have learned 3 times 3 factorial 2 is 6. 3 cross 2 cross 1. That means there are 6 chances of permutation and training. That means 6 times it will go ahead and check how 100 is associated with 25,000, how this 100 is associated with 25,000, and how this 1,000 is associated with 27,000, how this 1,000 is associated with 30,000, how this 1,200 is associated. So it will identify 6 times. 3 cross 2, 3 cross 2, which is 3, 2, 6, 1. So it is 6 times it will go ahead and do train. It will go ahead and identify. So somewhere it will come to a conclusion that, Kumar, based upon your input. What is the input here? The input is area. I am able to go ahead and see that you are getting output based upon this function. It is giving me based upon the function that I have identified. The relation that you can see is some m times area plus some value constant. It is able to go ahead and get to a conclusion. Kumar, I am able to go ahead and come to a conclusion that whatever the area that you give me, right, I will go ahead and multiply with this m, and I'll give you multiply with constant. So what would happen? It will go ahead and give me some value. That value we call it as predicted value. But the real value is what? The real value is 35,000. I'm able to do prediction. Now comes the very interesting thing. Participants, I'll ask you one simple question. Do you think machine understand area, machine understand $1,000, machine understand 25,000, machine understands rent? Participants, do you think machine will understand all of this? What machine understands? Can anyone guess? What does machine understand? Wonderful. It can understand only bits. What are those bits? Ta-ta-dine, zeros and one. It can only understand either a 0 or 1. That is basically bits, input and output, zeros and 1. So participants, can you connect what I am trying to highlight here? Participants, can you connect what I am trying to highlight here? If machine understands 0 and 1, what is my responsibility immediately after this? My responsibility is whatever you give it, whether your area, whether your rent, whether your $1,000, whether your 25,000, everything should be given to it in the form of ones and zero. So I welcome everyone to the machine learning capability where we as machine learning engineers are expected to go ahead and turn any piece of data in this world to ones and zeros. Now, did I justify what is machine learning now? So machine learning is nothing but a capability that we have to build where we go ahead and take the data. What is data? Now, just now I said area, rent, predictions. So all is this data. I will go ahead and turn it into ones and zeros. So it is my immediate responsibility that lies on my shoulder that I need to take my data. I need to break it down into zeros and ones because machine understands. If machine understands, machine will start doing the training for it. In order to training, it needs to be given a RAM, like a compute machine to be given a RAM and a mother, hard disk to store your data. So if this is what is machine learning, then what is the buzz? What is the great thing out of it? The problem that we live in this world is machine learning is just something that we see. It's only that we go ahead and take the data, we go ahead and give it to the machine, and machine starts to training. That's all. But the problem lies is that what you want after that, right? What do you want the machine to take? Will machine takes action? No, machine cannot take an action. Do you think after getting area, machine will start do anything? Nothing. It won't take any action. That is where artificial intelligence comes into picture. So what we do, we take a machine, we take that machine and we give all the data. So the machine, what it will do, it will take the data, break down into ones and zeros, identify the pattern in that ones and zeros, and come to a conclusion that based upon the area, I'm able to do a prediction. Based upon the data of ones and zeros, I'm able to do prediction for it, but it cannot take an action. This action capability is given to intelligence. That means in order to be intelligent, machine is not intelligent, by the way. Machine is a very dumb guy. Machine cannot do anything. In order to go ahead and make machine to take actions just like humans, what we do, we go ahead and build intelligence into that machine. But it's not a natural intelligence that we get from our birth. It is something which we induce. That means we go ahead and give it to the machine. So when we go ahead and give machine an intelligence, which is not natural, so that's how artificial intelligence has come up. So artificial intelligence is nothing but an induced human intelligence where it can start taking actions. The machine can start taking actions. If machines have to take action, it needs to be intelligent. So how is that you will induce intelligence? By making machine to learn something. Participants, are you correcting me? Are you connecting with me, everyone? Participants, are you able to connect with me? So
Oh, yes,
if you
yes.
want, right, if you want your machine to take actions, you need to induce intelligence into it. Like in our childhood, when we don't know anything, when the number was given to say the one looks something like this, so we learned that the number looks one something like this. We were induced by what is A, what is B, what is C, characters. Then we started to learn words. Then we started to frame sentences. Then we started to talk. Then we learned about the mother tongue. Then we have connections with the foreign language, English. Then we started to go and talk to the people when we go and understand the sign. Because this has happened from our childhood. From childhood, we learned, we repeated those. That's how you will go ahead and make intelligence out of the human. But machines are not like that. Machines, they're just, what do you call it, as transistors, what they are expected to do. So we have to induce an intelligence into those machines, that those machines are intelligent to take actions. So if you understand this very basic concept, then we are good to go ahead and explore the machine learning capabilities. Do you have any questions for me here, participants? Can I take any of your questions here? I hope I'm not making you bored. Participants, I hope I'm not making you bored. Everyone, are we good? Can I proceed with your permission? Participants, can I proceed with your permission?
Yeah, sure.
Right. Now comes the interesting part. The interesting part is you have started to go ahead and develop a model or trying to do. But how is this applicable in real world? See, anything which do not have any real world, you know, anything which is not able to solve a real world problem will not be considered. For example, if I go and build something which is no significance in it, why people will go and buy it? If you are able to build something, when people are able to take benefit out of it, where something real world problem you're trying to, then people will invest in it. So let me give you some real world how machine learning has solved the problem. Then you will connect what machine learning has in real world. So let's understand this one by taking a problem. So first we have to understand what are we trying to solve. We are trying to solve a very big problem. I'll tell you one of the problem. The problem, for example, is I work for a bank, or this is an example that I will go and talk about. A bank will always have to go and take care of their fraudulent transactions. What is meant by fraudulent transaction? The transaction that is not authorized by the holder, the card holder. That means he's not the one who made the card. So we want to go and predict whether this card transaction was done by the original owner. If it is yes, then no problem. But if it is not done, there is a problem. That's a big problem for a company, for an organization, for a bank. So how is that we are trying to solve that problem using machine learning? So that's basically we'll start framing the problem. The problem is, can I go ahead and solve the problem using machine learning? That's the first stage in machine learning. We're trying to solve the critical problem. We'll understand the problem. For that, what we need, can you guess, participants, what we need to go ahead and connect to solve the problem? What is that we need to go ahead and connect with? Any guess? If you are trying to solve a problem using machine learning, you identify the problem. So what are we expected to have with you? Any guess? Perfect answer by Vipul. That is nothing but your data. So what is that I need to have? The data. What is the data? Banking data that is done for a period of maybe say about an year or 2 years or 5 years. For the last 5 years, what are the transactions that have taken place? So I need to go ahead and collect all the data. So for the last 5 years, if there are any transactions that are fraudulent or that are non-fraudulent, I want to go ahead and take that data and I want to give it to the machine. So machine starts understanding that data and it starts giving me that based upon this data that I got trained, there is something that if it is not fitting into this data, that is basically a fraudulent data, fraudulent transaction. Participants, are you now able to get the importance of data? Participants, are you able to get to the importance of the data? Right? Now let's go and understand similar other problems. So other problems are like, I have a e-commerce application where people are buying products for me. But what I want to do is I want to make people buy more items. So how can you go ahead and predict? We can go ahead and predict based on the behavior of the customer. So let's say if the customer is buying some electronic product, maybe he is buying a mobile. So upon buying his mobile, what are the other alternatives that I can go ahead and use? I can go ahead and offer him buying along with the application of mobile, a case for the mobile, a screen guard for the mobile. Nowadays, we are getting Bluetooth enabled, headsets. We can enable that. We can go ahead and we can go ahead and recommend to the customer that if you are buying a mobile phone, why don't you go ahead and opt it? Why? Based upon the behavior. Maybe the machine has understood that the customer has bought a mobile application. Previously, people who have brought the mobile phone in the electronics category have bought, headsets, cover to the mobile, and screen guard to the mobile, chargers to the mobile, and some kind of insurance. So we should be able to go ahead and build a machine learning model using ML to solve a problem of an e-commerce application where the e-commerce application suggests some similar products. If you open up Amazon, if you go and buy some products in this, if you start to scroll down, you will see the machine learning application starting to give similar products. So it will tell you, go and buy some similar products. I hope participants, are we going good? Participants, are we good? Have any questions for me? Welcome. Now, the next step is another example is, let's say I'm watching videos based upon some interest. My interest is purely into action. I'm a very action oriented. If I watch a movie, my movie should have actions. But if I go ahead and start watching movies and suddenly comedy starts to pop up, I will have very little interest in watching comedy and drama. I'm not a drama person. I don't like dramas at all. But if I start getting recommendations of drama, one time, two times, I might like it, but next time I'll start ignoring them. That means my model is not able to give me right predictions or right recommendations based upon the choice of the movies I saw. If I go and watch a movie like Salar today, it should go and give me another movie similar to Salar, but not a movie which is something like, a comedy movie. I don't like to watch comedy movie at this moment. I like to watch, something which is more fascinating in the form of action. So this is basically a recommendation engine. And followed by another example is loan application. So let's say if we go and track a 5 years data of people who bought the loans, there are some points where there is a very great chance that a customer might buy a loan if he is being offered a loan. So what are the chances that a customer will buy? Let's say there are about 10,000 customers, and if you go and run a model where it will go and tell you that out of 10,000, there is 90% of chance that there are about 100 customers. If you go and target them, there is a very great chance that the customer might buy. That means out of 10,000 people, I have only 100 potential customers. Now I should go and target those 100 potential customers. That's how my bank will save a lot of time. Instead of focusing on those 10,000 people, I will focus on those 100 people who have great potential, 90% of the accuracy. The model said that if you go to this customer, there is 100% chance he will buy it. So there is a very great chance for these 100 customers when they will buy the loan. So we have tried to solve a problem. What is that problem? The problem of recommendations that were not available earlier. We are trying to solve a problem of identifying the right customers. Now we are able to solve that problem. Now, participants, I hope you understood the problem, and I hope you understood how machine learning will go ahead and solve this problem. Can I have a confirmation, people? Can I proceed a little further from here? You have any questions for me? Participants, do you have any questions for me? Okay, fine. If you don't have any questions, let me take a little further. So I have discussed the goal and what is the solution out of it. And I'm giving the solutions and framing the problems. Now we are trying to solve the problem using machine learning. So we'll try to understand the problem as I've been mentioning the features, the problem, and I'm trying to go ahead and give you the solution. So the problem was identifying the fraudulent transactions, and so that purchases does not take place, streaming. So we should be able to go ahead and predict what exactly is the next click of that user. Loan application, recommending the right place, so predictions to the users so that they can apply to the loan. So we are trying to solve the problem by using the machine learning. Now this might look very good, this might look very good, but let me talk about this in the world of machine learning. So how machine learning will go and say, machine learning will say that, let's understand take a graph and let's understand a person who, let's draw a line, or let's draw a graph where there is a line where the person will make loan, there is yes. That means this column, it's all about yes, and this column is all about no. That means a customer might purchase a product, yes. That means all your data points, people who have collected, that means this is a graph where you get to see all the people buying it, and this is a graph where people are not buying it. Prediction whether he will buy a loan. So this concept, we call it as classification. Now what is that we are classifying? Buy a loan. This is a prediction that I want to see. What are the options? Either there can be yes, he is buying the loan, or there is an option, there is no. So I need to classify based upon the customer information. What do I need to do? I need to go ahead and classify. So what is that classification called as? An algorithm that can go ahead and classify. That means can make predictions whether he will buy a loan or whether he will not buy a loan. That is yes or no. This concept, we call it as classification. Now, I'm talking in the sense of machine learning. In machine learning, we have this algorithm called classification, which basically does go ahead and focus on classifying whether he will buy or whether he will not buy. Another real world example. In real world, you might have seen spam. So how is that Gmail is able to go ahead and tell whether this email is spam or not? It will go ahead and look at some keywords like lottery. It will go ahead and look for keywords like you claims, lottery, benefits, bonus. So all these keywords that an email scans through, it terms it as spam. If it is not, it will go ahead and say, hey, it is not a spam. So the concept that I'm trying to highlight is we are trying to go ahead and consider the concept of a classification. I'm trying to go ahead and identify a model based upon the model algorithm called classification. We are classifying whether it is a spam or not a spam. Participants, I hope I'm going good. I hope I'm not making you bored, everyone. Participants, am I going good? Have any questions for me? If there is a quick yes, can I have a quick yes from all of you? Can I see a thumbs up? Everyone? See, I'm trying to come with a lot of information. I want to go and give you more information, but if I don't get to see attention from your side, it's kind of a demotivation that will happen. So keep me motivated. If you have any questions, if you don't understand it, do let me know. The more thumbs up, more keeps me motivated, right? Fine. Now, this is the one part of the story. That is, you just saw the one part of the coin. The other part of the coin is how you go ahead and deploy the model. Very, very important thing. So I want to go ahead and move a little aside because we have understood the importance of data. Now I want to do is I want to go ahead and focus on the deployment of the model. What is deployment? See, a developer sitting in your office, right? A developer is sitting in your office. He is a machine learning engineer. He has written a model which is able to tell whether there is 90% accuracy. It is able to tell whether this customer will buy loan or no. He developed a code, some 5,000 lines of code he has written. He is an amazing guy. His job is done. 5,000 lines of code he has written. Now the problem is this code which is written is inside his laptop, right? Or he might go ahead and use some kind of other source where he will go ahead and keep the code. We generally call it as version control, VC. VC means not venture capitalist, but it is VC here is version control. He will go ahead and put the code in a version control like Git. I hope you are aware of it. Git. Now this is very popular tool where they go ahead and generally keep the code. Now, the biggest problem that we have seen for the last few years is that developers spend 100% of their time in developing the model, but the problem happen is that the developer's code is not getting pushed into production. Production means live. It is not live. They're not getting live. So to make you understand, let me go ahead and give you this algorithm, this response. Can you see the response, everyone? Can you see the response? Participants, do you see a response here as screen? What is the summary of this response was? People were called. Hey, developer, come here. We want to take a survey. That survey, the question there are, how much time are you spending to develop the model? And how much time is taking to deploy that model? What are their answers? They said almost a quarter. That means 4 months and beyond. It's really, really challenging, people, because just in a day, the data changes. Imagine 4 months. That means data might have already changed. That means your model is not able to get that capability where the developer has spent almost months of time to develop this model, but the problem we are not able to deploy it. That means if it is taking 4 months, imagine what will happen on the fifth month? Maybe model may not be able to predict, or model is giving you inaccurate. The problem is the time that is taking place. What is the time? The time which is expected to go ahead and deploy the model, it is taking more than a quarter or more than that. That means developer is on this side where he is developing the machine learning model, and the time to deliver this is happening here. That means almost 8 to 10 months to get this model. Why? Developer is already taking his own time, 3 to 4 months to develop a model, and the deployment team is also taking another 4 months. That means almost 8 to 10 months. That means a company which is expected to deliver this project, get the project delivered, has to wait almost a year to make it into prod. Oh, come on. If this is the way things will work, they will drop the MLOps project. Nobody would be interested because we live in the world of instant, right? What is meant by instant? Immediately I want it. People, it's true. It's very true that people are looking forward for instant things. I apologize. Right. So people are living in a world, today's world is all about instant. That means the moment you develop, I want that to be done. So this concept has been there, and a lot of companies, I hope you are aware of this concept. This concept is becoming very popular, and that has already been there. A lot of companies have already done this. The concept we call it as DevOps. Now, what is DevOps? If you don't know, fine, it's okay. Even if you are aware, that's amazing. DevOps is basically nothing but the fastest way to release the application. That's all. The fastest way to release an app. In my definition, if you ask me, I will say, what is the fastest way to see? Even if you are driving your vehicle, the moment you look for your destination, what do? You will not take in economical route. Let's say the economical route cost you maybe 700 kilometers if you are to drive from Hyderabad to Bangalore. And if you take a fast lane which takes about 600 kilometers from Hyderabad to Bangalore, right? The problem is we better prefer to go and drive this way, fastest lane, rather than spending time on an economical. Because gone are the days who will be waiting for another 100 kilometers. Nobody interested. We want to take a fast lane. We want to drive in the fast lane. We are ready to spend some extra time or extra money so that we can reach in the fastest way from Hyderabad to Bangalore and save the money. So this is what exactly DevOps has been doing for a very, very long time. DevOps is there. So what DevOps has done? DevOps has done the way that the applications are developed and deployed. They found the fastest way. What is that fastest way to do? So this is basically the motivation for your MLOps. So what is basically the motivation if you ask me? The motivation for the MLOps is what is the fastest way to deploy. What is that? What to deploy? To deploy what? The machine learning code, ML code. And that is the answer for MLOps. Participants, are you everyone with me? If you can deliver an application the fastest way, then we should also find the fastest way to deploy it. The answer for all of you is nothing but MLOps. If the answer is very much satisfying, can I have a quick thumbs up from all of you people? Can I have a quick thumbs up from all of you?
Yeah, I have a quick question.
I'll take up your question, please. Please go ahead.
So when you say machine learning code, is that the same thing with models? Like machine learning code, machine learning models, are they the same thing or different?
Wonderful question. So let me take up this question. So what is that you understand is what is machine learning? So machine learning is nothing but the way you make machine say, hey, hello machine, good morning to you. I want you to go ahead and read the data, right? I want you to read the data, and with the data that is given to you, you go ahead and construct a relation. Now, writing this code is nothing. You can write this code in Python, which is the popular option, followed by you can write in R, you can write in Java, any other language if you are comfortable with any of it. So you can write it. So machine learning is nothing but an engineering principle that makes machine to learn about data, construct the relation in any of that language. Model is nothing but an outcome of it. What is that model? Model is nothing but an output. When you run a training, when you do a training with that data, the outcome you get, we call it as model. I hope now you are able to relate.
Yes, yes, very correct. Thank you.
Welcome. Now, I have a lot of questions coming in. Participants, do not worry. I'm all time here to take up all your questions. Now, let's go ahead and break down the idea of, let me go ahead and take these questions and let me answer a few of them. Okay. Now, the point is how to go ahead and deliver MLOps. Now, the question is how can we go ahead and develop MLOps? So, in order to go ahead and start developing MLOps, there are a lot of things that to be taken. Basically, we need to get the principles of DevOps. So, what is that we need to do is we need to take uh, the DevOps principles. From the DevOps principles, we should be able to go ahead and build it. So now, what is that? We have already learned about the machine learning solving a problem, right, with the help of data and trying to go ahead and use the principles of machine learning. So that's how the concept of MLOps come in. So if you look at the DevOps, in order to carry out DevOps, there are certain things which will be a little difficult for you to understand at this moment, but let me help you to understand. So we need a stage where we can go ahead and take care of the source that is written by the developer. So we need to handle source code. After the source code, we need to focus on building those models, right? What is that we need to do is we need to focus on build those models. Participants, if you're not getting anything, do not worry about it. These are certain stages, right? After that, we need to go ahead and train the model. That's how we call it as continuous training. We need to train the model. Then what we need to develop is we need to develop the artifact, which is basically the model we will go. We need to go ahead and store that model. For that storing, we need a registry to the train model. Next, we need to go ahead and focus on deploying that model. What we need to do, we need to go ahead and deploy that model. So we are starting from source where we will go ahead and write the code, we build it, we train the model, we develop the model, we store that model in the registry, we deploy it. Now, coming to the deployment, there are various strategies that are followed. But if I go ahead and start talking about it, it will be very confusing. At this moment, the very popular strategy that is being followed is Kubernetes platform. Even if you don't understand a line about Kubernetes, do not worry. Kubernetes is basically an open source container orchestration where machine learning engineers they develop the code. DevOps engineer will go ahead and build that model, take that code, build it, train it, develop the model, focus. They use the deployment and deploy it into Kubernetes. If you're very new to Kubernetes, if you don't know what is Kubernetes, Kubernetes is nothing but a very, very popular concept that is actually taking over MLOps. So if you are very new to Kubernetes, just visualize Kubernetes is nothing but open source system that is getting your machine learning models deployed in the form of images and you run it across Kubernetes. So this Kubernetes is now picking up this platform of DevOps. A lot of companies have adapted to this. So that's how you need to build a skill. That means if you want to become an MLOps engineer, you need to gather all these skills, right? From source, build, training, testing, deployment, and container. This is one of the core skills that you should focus to deploy the models because that is where your major contribution will be onto the deployment of the model. And Kubernetes is one such skill that you need to build. Participants, everyone, are you with me now? Participants, are you with me? Okay. So now, if you look at the content, if you look at the content that we have designed for this training program, we have followed the same principles that whatever I've been discussing. So we will get started to understand the concepts of, version control. Basically, we'll start understanding what is version control, what are the benefits of bringing the version control. Then we will focus on model. What is model? You are writing a Python code where you go ahead and understand the relation across the data points, and you will be able to come to a decision that based upon the model that I've developed, I'm able to go ahead and build a model, and that model is able to go ahead and do the predictions or some classifications, some kind of model development. It is better to have a skill which is not recommended, but since I come from the machine learning background, I feel if you have a little bit knowledge about the algorithms, model development, the various stages, that is going to be helping you a lot. But this is where you will not be able to go ahead and greatly build your skill. But if you have the knowledge and idea about the model development, agreed. But if you focus on MLOps more, this is where your skills are to be built. You need to understand Dockers to build your models and turn them into Docker images. Then you need to deploy it across the Kubernetes environment, Kubernetes. Then you need to go ahead and use Kubeflow, the game changer in the space of MLOps. So for deploying into Kubernetes, we should get adapted to the Kubeflow. So what is Kubeflow? What are the various services under the Kubeflow we will be bringing up here? We'll start it. And this is purely open source. Some interesting things that whatever the models that we are taking up, everything is open source. Python is open source. Git is open source. Model development, Docker is open source. Kubernetes is open source. We want to go ahead and maintain zero billing for you so you don't get invested for all other resources. We're trying to use as much as open source, followed by the various stages of model development, deployment, and then we will start focusing on a very, very key principle, that is CI/CD. Now, I know if I go ahead and talk about CI/CD, it will be very confusing. Just let me go ahead and give you an answer for the CI. So you can just visualize this as nothing but your CI and this as your CD. What is CI? Where we go ahead and get the data, exploratory data analysis, data prep, model development, training the model. This is all about machine learning, continuous integration. Continuously, we train our model. When it comes to deployment, we deploy the model, we monitor it, we infer it, we continuously do the deployment. So this is how the CI/CD principles in real life will be utilized here. So participants, are you catching up with me, everyone? Participants, everyone, are you catching up with me? Participants, are you with me? Okay. So now, if you go ahead and look at the skill of MLOps, let me summarize the skill of MLOps in this way. Build a little bit about model development, stages of the model, what is basically a model, how to develop a model, how to build a model, how to deploy. That basic essentials, if you have, awesome. Next, focus 70 to 80% of your learning on model deployment, because that is where you will be adding value addition, like Docker, image building, continuous image building, right? Deployment of Kubernetes environment, integration with Kubeflow. This should be your focus. Now, if I go ahead and ask you, hey, come on, guys, let's go ahead and build machine learning, that will not be a major contributor. That will be only 30% of your skill. Don't expect that today, if you learn MLOps, you will be able to write models. No, that is a wrong perception. Don't focus on that. It is better to have a basic knowledge about model development, model deployment. I agree with you. That is something which is fine. But your focus, 70% of your focus should be attained towards deployment. Like you should understand what is Docker, how to go ahead and build machine learning models involving Dockers, how to go ahead and build Docker images, how to go ahead and pull out Kubernetes environment, how to go ahead and do deployments, how to go ahead and involve services. Lot about deployment you should focus. My target is you should have good skill in deploying those built models. Like when I started If you want, I will go ahead and build a model which can do prediction for your area and your rent. I will give you that model. You learn how to deploy that model into production. Participants, everyone are with me? Now I'll summarize it. If you want, let me go ahead and take the role of a developer and I'll go ahead and build the model for you. That's how things happen in real life also. You will not be going ahead and building the model. No way. Basically, you will go ahead and take that model and deploy that model into prod. But what is that we are trying to do? We are trying to build a little more skill on model development, model stage. Then we are trying to go ahead and deploy that model. So that's what I said. 30% you focus on training your model, development of your model, but 70% focus containerization, Dockerization, image building, Kubernetes, service deployments, monitoring, maintenance, continuous integration, continuous delivery. This is your skill. This is something which I recommend as I've been involving MLOps. So in ultimate summary, now the summary, quick summary. If you want to become an MLOps engineer, a month from now, you have to dedicate for yourself. And in that month, you should be learning the concepts of machine learning. Okay, once you understand the concepts of machine learning, the various stages in it, you should focus more on deploying that model. If you learn the skill of deploying the model, I'm telling you, there's a lot of opportunities where you can go ahead and justify your skill to an organization that I have been a DevOps engineer earlier. You can go ahead and tell this way. I have been a DevOps engineer. I have built a skill of machine learning. I understand the machine learning concepts. I have utilized the machine learning concept to deploy it across Kubernetes container environment. So I am a right person to get hired for this MLOps position. So participants, if I justified this definition where, because I started with saying that by end of the session, I'll justify that you have taken the right subject. So if you have seen that I've justified it, can I have a quick round of thumbs up from all of you? Hope you remember I started with saying that I'm going to go ahead and justify by end of the session that you have taken a right. So thank you for your confirmations and thanks for your thumbs up. So I don't want to, mess up more. I want to, take your questions because I don't want to talk. Let you people talk and give me your questions and I'll start taking your questions and I'll start answering them. Can I take your questions, please? So I saw a few questions. The first question was from Sriram Satyam. Do we need to create a model? I answered it. 30% if you build a skill on model development, that will be suffice. But 70% focus on deployment of the model. That is my answer. Yeah. Next question, please.
I
Okay.
have a question here. I just want to add one more question, a follow-up question. So let's suppose uh, I have full knowledge on DevOps part. I totally understand Docker, Kubernetes, Prometheus, and everything, right? I understand CI/CD as well. So on top of that, if I see, so for deploying models, we are using one particular tool that is Kubeflow, that is open source, right? But I see organizations are using Kubeflow, but more preference are giving to the SageMaker and ML Studio kind of tools. Okay, so I think that is not a part of syllabus. And if it would be better to, if we can create some sort of model also in the class, that would be a benefit, because uh, because I see
Okay. I'll make your life easy. I got your
mm,
question.
mm,
If you want to go ahead and use the sources like AWS SageMaker and other
mm,
sources, the
mm,
billing of those sources would be around $1,000 for this entire training program. So that is the reason I have been asking the team that
mm,
we will only go ahead and utilize open source tool. And for that same reason, we have included Kubeflow, which is open source and free of cost. We have been able to take the concepts of SageMaker. We will go ahead and use the concept. But the problem is, if you go ahead and replicate the concepts of SageMaker into your own practice, it would cost not more than $1,000 because it is not a billing that will take place per hour to hour. It will take more amount of billing per second to second billing. and it is very, very expensive service. If you go and not be able to handle it, $1,000, 1,500, 3,000 US dollars would be the billing. So we don't want to go ahead and get people and
O-
students into a situation
Okay,
where you, right? So we don't
okay, I
want it.
got it. I got it. Mm. So
Right.
when we say like, okay, we are going with Kubeflow, so you need to install Kubeflow on Kubernetes, right? So what is the plan? So where we are going to create the Kubernetes cluster? We need the cluster, right? So cluster are we going to create in on a cloud, or how will we creating it?
Okay, Satyam, you have a lot of questions. If you want, we can have a separate discussion on it, but I'm trying to answer the question in a straightforward way. Your local
Mhm,
machines are your answers. We will pick up our local machines. We will install local machines. We will have Kubernetes installed on our local machines. If you want, you can go ahead and install it on your AWS EKS, on Azure AKS, or Google GK.
okay.
But it's absolutely the responsibility of yours to take care of those clusters, because if you spin up those clusters and if you just leave them, by end of the day you will get some hundreds of billing into your account. So I would request you, just go ahead and utilize your local machine capabilities that are quite sufficient, and we are also in the process of integrating if it is required to integrate with the cloud provider. So give us some more time where we will focus on the integration with the other, where we want you to practice on our in your local machines with zero billing, zero amount of price per your practice. But when it comes to the integration with the cloud providers, we are just focusing on getting integration with the cloud. So we'll give you an update in some time. Okay,
Mhm.
right. You have any more questions, Satyam? You have any more questions?
Yeah, I can connect separately.
Fair. Participants, do you have any more questions for me? Do you have any questions?
Yes,
Can
yes.
you please
So,
mute for a minute, Satyam?
yeah. So I'm
Yes,
Santosh here.
please.
Yeah. So I
Yes,
have a
Santosh,
question
please.
like, if you completed this course, how many years can I claim like that, or 2 or 3 in 1 year MLOps is? Can I say that? Because I'm a QA engineer, more than 13 years experience. I know little bit knowledge on like, not small, very knowledge on DevOps. Okay, so I have little bit knowledge on ML regular model. So this
Okay,
is my background. Yeah.
sure. I'll try to answer. If I was in your position, I would have been little bit strategic. You know what is meant by strategic here? Let me explain you. See, I, y- if I was in your position, you said that you have 13 years of experience. Now, the problem is if you go ahead and tell that in 13 years of experience, whatever the current experience, if you go, there is a very great chance that might not be relevant. That is basically, if you look at the relevant experience, it is not something which is going to be value added. Correct? Correct, Santosh? Now, what I would have done is I would have done in this way that out of the 13 years of experience, I would have gone ahead and utilized that for the past 8 years, I would have been mentioning that I have been into, whatever the current role. You said that you are into a QA. QA plus, I would have gone ahead and said, I have been working for the last 5 years in working with the projects where the projects were primarily into the DevOps projects, where I have gone ahead and built the skill of DevOps. And in the last few years, maybe around 2 to 3 years, that I have been working in the same 5 years also. I've been working where the projects involve, machine learning, model development, model deployment, and also some kind of, non-ML applications. But I am skilled with both non-ML applications, ML applications with regards to DevOps. So totally, you're trying to go and project out of your 13 years of experience, 8 years purely, QA consultant. But the last 5 years, I had an opportunity to go ahead and work with the DevOps pipelines, where I have worked for both ML and non-ML applications. If this is the way that you can go ahead and portray yourself, very great chances that the interviewers will understand that you are a fully skilled 13 years skilled employee with some relevant years of experience, that is basically focusing machine learning, MLOps, and so that is how you can justify it. And this is what companies look for. They don't expect, out of 13 years or 13 years, you're expected to have machine learning or a DevOps. So it is better to go and it is better to go and give better to go and give them a value that I am about relevant years of experience is about 4 to 5 years when come to DevOps, MLOps, and the full length experience has been into your expertise. So justified, Santosh?
Yes, yes, you were. Thanks. And final question, like, how is the market in India and US? So US
Right.
service.
From my personal experience, it's been for 10 plus years, I've been into DevOps and MLOps. For the first time, when I got introduced to MLOps, even I was not sure. Like around 2016, I had worked with a banking and financial company where they were trying to go and build models at that time. And the models that they were building were primarily on all about loans application, how the customer will go ahead and make the loans or what is their turnaround. So what I've seen is that for 2016 to 2018 or 2019, there was no great solutions, no great projects around it. But what happened when Kubernetes started to go ahead and attract more and more projects, a lot of open source project around Kubernetes have come up. A lot of projects have come up. So this was one MLOps was one such concept that have really gained popularity with Kubernetes. And from 2019, there has been a very great and steady, what you call it as growth for Kubeflow, Kubernetes plus machine learning capabilities together. Kubeflow started. And the Kubeflow is now supporting the various cloud providers like AWS, Azure, and GCP. So as much as the cloud providers are buzzing this, the concept of MLOps, there is always a growth that you can expect for the next few years. So definitely because AWS, Azure, and GCP are actively promoting Kubernetes, are actively promoting machine learning deployments into their own, services like in Azure they have, in AWS we have, in GCP, and also the rise of Kubeflow. So because of this raise, you can expect the, opportunities to heavily flow both at US as well as in India. At least what I'm able to see, this is what I have been able to see. And what I can visualize is next 5 years, I can see there will be a tremendous growth for the model development, but there will be limited people who are building their skills on this capabilities like Kubeflow, Kubernetes, cloud. There will be always a space for it. So at least for next 5 to 10 years, you can expect there will be not much that competition, but definitely there will be a space for people like us who are built with machine learning and ops skills. So this is my answer for you.
Thank you very much.
Yeah. Any other questions?
Yeah, hi, sir.
Okay. I have. Okay, sorry. Let me take one question. So there is Giri Prasad Maheshwarwala. What is difference between DevOps and MLOps? When to use both? See, very simple. In DevOps, we don't know what is your application. Maybe a Java application, .NET application. We don't know. Forget about that application. We deploy that application. But when it comes to MLOps, we are aware that it is a machine learning. That means there is a Python code or an R code that is a machine learning code. We deploy that. That is a very simple way if you can understand the difference. That's how MLOps is. DevOps capabilities are used. It's like you're taking a vehicle to drive, right? But you're not having any driver. You're driving your own. Now, what is that? You're knowing your vehicle. You know your destination. You know everything. That's how MLOps is. Do we use Jenkins? Yes, we use Jenkins for our continuous integration purpose because it's an open source tool. I hope that answers your question, right? Fine. Yeah, next question, please. Sorry, I had to
Yeah,
stop you.
hello.
Please go ahead.
One last question, like a quick one. Sir, actually, like as you answered such a we are not completely taking taking a look in terms of SageMaker or Azure Studio, right? So, will we at least be covering uh, minimal operations like working with the T2 micro instance or something like that, so that we will get used to the cloud space as well? Why? Because um, we were asked to work on the cloud space in our company, so that's the reason I'm asking this.
Okay, I'll give you an answer for it. Easiest way. If
Mhm.
you can go ahead, and first important thing is that T2.micro is not going to be sufficient for your model development. The
Okay.
minimal needed is M4.large.
Okay.
Believe me,
Okay.
M4.large. So can you afford an M4.large instance for your training? The answer is absolutely no. I don't want you to do it. So what I will
Okay.
do is I will go ahead and give some space where you will be able to understand that how I'm going to go ahead and use Kubeflow integration with SageMaker. Is it fine?
Okay.
So I'll go ahead and
Yes.
spend
Yes.
some time where I've already developed the model.
Mm-hmm.
Docker image is built, everything is ready. Then we will take it to AWS SageMaker. That makes you happy?
Yep.
Done. Taken care.
Understood.
That is something
Thank
that I can take. But don't go ahead and replicate into your local machines. Don't go ahead and
you.
replicate
Sure.
your AWS scenarios because you might not be aware that AWS free tier do not support SageMaker. SageMaker is not available for free tier.
Yes.
You
Yes.
have to pay for it.
At
Little
least for my
maybe
like organization is gonna take care of those things. So that thing that I want to leverage that. That's the reason I'm putting this up.
I think if everybody has the same thing, I don't have any problem. But the limitation is that it is not applicable for everyone.
True.
But let's
True. I understand.
let's be let's be very holistic in the approach that I'm going to
Sure.
go ahead and take those sessions in the SageMaker also. I'm not going to deny it because SageMaker without SageMaker and Kubeflow things won't work. Definitely, I'm going to go ahead and take sessions on the AWS SageMaker also. Fine,
Thank you, sir. Thank you, sir.
welcome. Any other question, participants?
This is Sunil. Okay, if you learn this MLOps, are you going to teach the architect level also?
Can you be very specific about that question because I never heard about the word architect in MLOps. Can you be very specific on it?
No, you are going to teach about the model deployment, or are you going to teach the some concepts which are related to architect level also?
Okay. So the idea is very simple. You start as a fresher or you are starting from ground zero. You will first understand the problem. You will understand the data. You will design a model. You develop a model. You build a continuous model. You deploy that model. From there, we will start taking the advantage of Dockerization, containerization, Kubernetes. So that's already helping us to build an architecture around it. So there is no specific that you should go and build an architect skill. In order to build a model, you need to understand the architecture skills of how architecture is built for the deployment purpose. For the deployment purpose, yes, there should be an architecture. But for the model development, you don't need it. You just need to go and focus on data, training the model, developing the model, and deploying the model. Hope that answers your question, Sunil.
Yeah, understood. Yeah, thank you.
Welcome. Okay, so participants, I know a lot of questions can come in, a lot of things can come in. Do not worry, I'm always there for you. My name is Siddharth, and Siddharth is going to be there with you people if you have any questions. May not be today, I may be able to answer all your questions, but for sure, I will start taking all of your questions. And there is always a space for me to go ahead and give you what you want. See, I can give you what is that you want if you can give me space. So it's a space that we have to create it. So what is that space is compile your questions for the next session. Get ready for the next question. So what we will do for the next session, we will go ahead and take a little more time to go ahead and get those answers question. So just now I had a word with the team. We will have another session which is going to be happening on Monday. So if you can make yourself Monday, which is going to be from 8 o'clock to 9 o'clock, come up with a lot of questions if you have. Let's spend time to take those questions. So is that fine for all of you people? Because I don't want to stretch beyond this because I know it's been more than 1 hour, almost 20, 30 minutes. So compile your questions, do a little more research and come back to me on Monday so that I can take your questions and I can answer them as well. So is it a fine? Can I have a quick thumbs up so that we can conclude the session here? Okay, fine. Once again, thank you to all the participants to making out to this part of the session. And I'm concluding the session here. Thank you once again. Thank you, everyone.